Now we see the non-deterministic finite automata with epsilon move. Okay, see here there are 5 tuples. This non-deterministic finite automata with epsilon is called as epsilon NFA, which has 5 tuples. M is equal to q summation delta q0 f, where q0 is nothing but finite set of states, summation is nothing but finite set of input alphabets, delta means what? Transition mapping function which maps q cross. Now see here, in simple NFA we can write the delta function, delta, that is the transition mapping function, as q cross summation gives you 2 raised to q. But here in non-deterministic finite automata with epsilon, here we can q cross summation union epsilon gives you 2 raised to q, that is the power set of a q. Here we can united epsilon with the input alphabet. Okay, q0 is the initial state and f is a final set of final states. Okay, this is the epsilon NFA. Okay, now see the next point is that epsilon closure. Definition of a epsilon closure of Q, that is, it is the epsilon closure of a Q which contains the set of all states P such that there is a path from Q to P labeled epsilon, which is denoted by this symbol, that is epsilon. Note that it is also known as the set of states which distance 0 from state Q. That means the distance of any state from itself is 0. That is called as epsilon closure of that particular state. Okay. Thamba. Now see the example. From this example we can calculate the epsilon closure of a given states. See here there are 3 states, Q0, Q1 and Q2. Q0 is the initial state, Q2 is the final state. Now we can calculate the epsilon closure of each state. First we have to calculate epsilon closure of a Q0. That means epsilon closure means what? The distance from itself is, the distance 0 from itself is called as a epsilon closure, and the path from state Q to P is labeled as a epsilon, that is also called as a epsilon closure of that state. Now see here, epsilon closure of a Q0 is the distance 0 from itself, that is Q0 itself. So here we can write Q0 first. Okay, Q0, the distance 0 from itself. Okay, that's why here we can write Q0. Again, from Q0 the epsilon is goes to another state. Okay, that is the edge which is labeled as a epsilon. Okay, that is the Q1. From Q0 to Q1 there is a epsilon edge, so we can add here Q1 also. Again, from Q1 to Q2 there is another edge that is labeled as epsilon, so therefore here we can add Q2 also. Okay, that is the epsilon closure of a Q0. Okay, now see here, epsilon closure of Q1. Okay, epsilon closure of a Q1. Now see here, first of all we can write the state itself. Okay, because the distance 0 from itself, so here we can add the Q1 itself, comma, from Q1 to Q2 there is a epsilon. Okay, which is, there is a edge which is labeled as epsilon, so here we can add Q2. Okay, Q1, Q2. Now see here, epsilon closure of a Q2. First of all we can add the Q2 itself, the distance 0 from itself, so here we can add Q2. Then there is no edge which is labeled as a epsilon. Okay, so that's why here the epsilon closure of a Q2 will be only Q2. That is the epsilon closure of a given states. Okay, see here, epsilon closure of a Q0 is Q0 itself, that means 0 distance from itself, and the edge which is labeled as epsilon from Q0 to Q1. So Q0 itself, then Q1, again there is a edge from Q1 to Q2 which is labeled as a epsilon, so here we can add Q2 also. Okay, same as epsilon closure of a Q1 will be Q1 itself, then Q2, and epsilon closure of a Q2 is Q2 itself, but there is a no edge which is labeled as a epsilon, that's why here we can only write a Q2. Okay, this is the epsilon closure of a given NFA. Okay. Okay. Now see here, next point is that conversion of epsilon NFA to DFA. See here, there is a one rule while converting epsilon NFA to DFA. The rule is that delta dash of Q comma A is equal to epsilon closure of delta cap Q comma epsilon comma input alphabet A. Okay. Now see here, delta cap of Q comma epsilon, which is the epsilon closure of a state Q. Okay, this is the rule. When we used this rule while converting a epsilon NFA to DFA, at that time we can use this rule. Delta dash of Q comma A is equal to epsilon closure of delta in bracket delta cap Q comma epsilon comma A, where delta cap of Q comma epsilon is the epsilon closure of a state Q. Okay. Now see the example. The example is that construct DFA equivalent to given NFA, which is asked for 5 marks. Okay. See here, the NFA with epsilon will be given here. So first we have to write the tuples. The given NFA is, okay, M is equal to Q summation delta Q0 and F. Okay, where Q is equal to, Q is nothing but Q0, Q1 and Q2. Okay, summation, that is the input alphabets are A comma B, and one another input alphabet is there, that is epsilon. See here, then Q0 will be Q0, that is the initial state, and F will be Q2. Okay, now here we can calculate the delta. See here, delta, how to calculate delta? Q cross summation union epsilon gives you 2 raised to Q. Okay, see here how to calculate a delta. Q cross summation Q0, Q1, Q2, and input alphabets are A and B. Now see here, Q0A gives to the Q1. Okay, Q0B is given to the Q0, Q1. See here, Q0, Q1. Okay, then Q0 epsilon is not present, so here we can add phi. Okay, so see here, Q1A, there is no edge from Q1, okay, labeled as A. Q1B not present, so here we can write phi. Q1 epsilon is there, okay, where it goes Q0, so here we can give Q0 as well as Q2. Okay, so Q0 as well as Q2, so here we can write Q0 comma Q2. Okay, Q0 comma Q0 comma Q2. Next, Q2, Q2A, Q2B itself, Q2A, Q2, Q2B, Q2. Okay, then Q2 epsilon, sorry, see here, Q2A will be Q2 itself as well as Q1. So here we can write Q1 comma Q2 as well as for B, Q2, B, Q2 as well as it gives to the Q1. So here B also we can write here Q1, Q2, and Q2 epsilon. Yes, here is the epsilon. Okay, see here, here is the epsilon gives to the Q0. Okay, so here we can write the Q0. Okay, this is the delta of the given epsilon NFA. Now here we can calculate the epsilon closure of a given states. Now see here, epsilon closure of a given states. Epsilon closure of Q0, epsilon closure of Q1, epsilon closure of Q2. See here. Now epsilon closure means what? The distance 0 from itself. That's why here we can add Q0 first of all. Then there is no edge which is labeled as a epsilon. So here the epsilon closure of Q0 will be Q0 itself. Then now see here, epsilon closure of a Q1. Q1 itself. Okay. Then there is a epsilon edge for from Q1 to Q0. Okay. Q1 to Q0. So here we can add Q0 as well as from Q1 to Q2. Okay. So here we can add Q2 as well as from Q2 to Q0. But already we can write here Q0. Okay. Therefore here the epsilon closure of a Q1 will be Q0, Q1 and Q2. Okay. Now see here, epsilon closure of a Q2. Q2 itself, then the epsilon edge is from Q2 to Q0. So here we can write Q0 comma Q2. Q2 itself, that is the distance 0 from itself. So here we can add Q2 as well as the epsilon edge, that is from Q2 to Q0. Okay. Therefore here we can write Q0 also. These are the epsilon closures of a states. Okay. Now here we can find out the delta dash, that means the DFA. Okay. Here we can calculate the delta dash as A. See here, this is the delta. Now here we can find out the delta dash. Okay. Q cross summation, which is the Q cross summation gives you Q. Okay. This is the delta or transition mapping function of a what? DFA. See here, here we can calculate the DFA. First we have to calculate delta dash. Here we can write the states A or B. Sorry, input alphabet A comma B, because DFA cannot contain epsilon. That's why here we cannot write the epsilon. Now first we have to add here the epsilon closure of a initial state. In this example or given NFA, Q0 is a initial state. Now the epsilon closure or E closure of a Q0 will be Q0. That's why here first state will be Q0. Now here we have to find out the delta dash of Q0 comma A, delta dash of Q0 comma B. How it is calculated? By using rule. Now see here, what is the rule? Delta dash of Q0, delta dash of Q0 A. How it is calculated? That is by using rule. Epsilon closure of delta cap state is Q0 comma epsilon comma input symbol is that A. Okay. Understand? Now see here, epsilon closure of delta of, what do you mean by this? Delta cap Q0 epsilon means what? Epsilon closure of a Q0. Epsilon closure of a Q0 will be Q0. Okay, comma A. Okay, now see here, epsilon closure of delta of Q0 comma A. Now see, epsilon closure in bracket delta Q0A. This is the delta Q0A. What is this? Q1. Okay, and finally here we can calculate the E closure or epsilon closure of a Q1. What is this Q1? Epsilon closure of a Q1 will be Q0, Q1, Q2. That is the delta dash of Q0A. Now write here, delta dash of Q0A. Delta dash of Q0A will be 0, 1, 2. Q0, Q1, Q2. Now here we have to find out the epsilon delta dash of Q0B. Okay, see here, epsilon closure of delta cap state will be Q0. Here we can add epsilon, comma, input symbol is B. Now see here, epsilon closure of delta. This is the epsilon closure of a Q0. Epsilon closure of a Q0 will be Q0, comma, B. Okay. Now see here, delta of Q0, comma, B. Delta of Q0, B. Delta of Q0, B. What is this? Q0, comma, Q1. Okay. Q0, comma, Q1. Delta of Q0, B, that is Q0, comma, Q1. Now see here, we can divide or distribute this epsilon closure to Q0 as well as Q1. See here, epsilon closure of Q0 union epsilon closure of Q1. See, here we can distribute the epsilon closure to Q0 and Q1. Epsilon closure of a Q0. Epsilon closure of a Q0 will be Q0. Okay. Union. Epsilon closure of a Q1. Epsilon closure of a Q1 will be, see here, Q0, Q1, Q2. Okay. So, the union of these two states, union of these two sets will be Q0, Q1, Q2. Q0, Q1, Q2. So, delta dash of Q0B will become Q0, Q1, Q2. Q0, Q1, Q2. Okay. Now, see here, after this state, next state will be the new state which will occurs in the delta dash. Which will the, which of the next state? That is the, see here, Q0, Q1, Q2. Q0, Q1, Q2, that is the new state. Okay. Now here we have to calculate the A of Q0, Q1, Q2 as well as B of the Q0, Q1, Q2. Okay. Now see here how it is calculated. See, epsilon, now see here how to calculate the A's and B's of a Q0, Q1, Q2. See here, delta dash of Q0, Q1, Q2, okay, comma, A. First we have to calculate the A is equal to epsilon closure of delta cap of states are, see here, Q0, Q1, Q2, okay, comma, epsilon on the input alphabet A. Now see here, epsilon closure of delta of. Now here we can distribute the delta cap. See here, delta cap of Q0 comma epsilon union delta cap of Q1 epsilon union delta cap of Q2 epsilon over the alphabet A. Okay. Now see here, epsilon closure of delta of, here delta cap Q0 epsilon means what? Epsilon closure of a Q0. Epsilon closure of a Q0 will be Q0. Okay. It is the set union. Delta cap of Q1 epsilon, that means the epsilon closure of a Q1. What is this? Q0, Q1, Q2. Okay. Union epsilon closure of a Q2. What is this? Q0, comma, Q2 over the alphabet A. Okay. Understand? Now see here, epsilon closure of, from this all, Q0 union Q0 Q1 will Q2 will become Q0 Q1 Q2. Again it will be united with this Q0 Q1 Q2, that becomes, see here, Q0 union Q0 Q1 Q2 will become Q0 Q1 Q2 union Q0 Q2. Again the union of these two sets will be Q0 Q1 and Q2. Okay. Now see here, finally delta of Q0 Q1 Q2 over the alphabet A. Okay. See here, epsilon closure of. Now again distribute this delta over the Q0 Q1 Q2. Delta Q0A union delta Q1A union delta Q2A. Okay. See here, epsilon closure of delta Q0A. delta Q0A, that is the Q1 union, delta Q1A, which is the phi, delta Q2A, what is this? Q1, Q2. Okay, now see here, epsilon closure of Q1 union phi Q1 and Q1 union Q1 Q2 will become Q1 Q2. Okay, now here again we can distribute the epsilon closure as a epsilon closure. See here I am writing epsilon closure of a what? Q1 union epsilon closure of a Q2. We can distribute here. Now see here, epsilon closure of a Q1 will be Q0 Q1 Q2. Okay, union epsilon closure of a Q2, that is the Q0 Q2. Okay, finally we can get the answer, that is Q0 Q1 Q2, that is the delta dash of Q0 Q1 Q2 B, A. So here we can write Q0 Q1 Q2. Okay, now here we have to find out the B. Okay, the B of Q0 Q1 Q2. How to find out this? Same like that. See here, how to find out Q0 Q1 Q2. The shortcut is that. Now see here, how to calculate it orally. Q0 Q1 Q2. Here we can write epsilon closure of delta cap of Q0 Q1 Q2. That means delta cap of Q0 epsilon, delta cap of Q1 epsilon, delta cap of Q2 epsilon. That means epsilon closure of these three elements. Okay, and then again after that we can united them. Okay, now see here, epsilon closure of a Q0 will be Q0 union epsilon closure of a Q1 will be Q0 Q1 Q2, and epsilon closure of a Q2 will be Q0 Q2. Okay, over the alphabet B. Okay, over the alphabet B. Now see here, epsilon closure of, here we can perform union operation. Q0 union Q0 Q1 Q2 will become Q0 Q1 Q2 union Q0 Q2, which will become Q0 Q1 Q2, Q0 Q1 Q2 over the alphabet B. Again we can distribute this delta. Okay, now see here, epsilon closure of delta Q0B, delta Q0B, Q0 Q1 union delta Q1B, delta Q1B, phi union delta Q2B, Q2B. Okay, what is this? Q1 Q2. Again we can perform union operation. Q0 Q1 union phi Q0 Q1. Okay, Q0 Q1 union Q1 Q2. Finally we can get the union Q0 Q1 Q2, Q0 Q1 Q2. Again we can perform the epsilon closure or distribute the epsilon closure in between Q0 Q1 Q2. Okay, then epsilon closure of a Q0 will be Q0 union epsilon closure of a Q1 Q0 Q1 Q2, epsilon closure of a Q2 Q0 Q2. Okay, first we have to perform union operation on these two sets. Q0 union Q0 Q1 Q2 will become Q0 Q1 Q2 union Q0 Q2. Again finally union of Q0 Q1 Q2 with Q0 Q2 will become Q0 Q1 Q2. That is the delta dash of Q0 Q1 Q2 over alphabet B will be Q0 Q1 Q2. Okay, so next state is that there is no next state because no new state will occur over the alphabet A or B. So we can stop here. Now we have to draw a DFA or transition diagram of this delta. Okay, now see here, the transition diagram of DFA is, how many states are there? Only two states, Q0 and Q0, Q1, Q2, which is the set. Okay, now see here, in original or given NFA, Q2 will be the final state. Now here in this set where Q2 will be present, that all states or sets will become final, because in the given NFA Q2 will be final state. Okay, in here delta dash, in delta dash there are number of states. Okay, in that all state where the Q2 will be present, that all states are final. So here only one state, that is have Q2, so this is the final state, and as usual Q0 is the initial state. So here we can write start. Now see here, Q0A, Q0, Q1, Q2. Okay, Q0B, Q0, Q1, Q2. See, Q0, Q1, Q2, A itself, B itself, that is the DFA. See here, this is the example of a conversion of a given epsilon NFA to the DFA. This is asked for 5 marks in theory exam. Okay, thank you.